Hey there, my calculus minions. I am making this video to try to give you some concrete advice about what to do with your um, Choice 1 and Choice 2 projects. It is, it's easy in its general sense, which is, hey, try to find some application for calculus or derivatives in any of these fields of your choosing. So now you've been given a chance to give a couple options, and hopefully you're finding that the one that you've been finally paired up with is not too bad. It's something that you kind of are interested in. And so I'm going to try to show you like what you can do to complete the requirements here, which says choose one field, done that, and research how the derivative plays a role in that topic. Okay, so that's pretty specific. It's a little bit more specific than just say, hey, calculus. Calculus can also be integrals, which is something we'll learn about at the end of this year. So stay away from integration or accumulated change or any of that terminology, and try to stick to rates of change and derivatives. Okay, write enough to fully explain how the field incorporates derivatives. And by derivatives, we're talking about an understanding of an instantaneous rate of change. Okay, and try to be more specific than just saying, oh, architects need to know about rates of change for the amount of load that a beam can carry when they're designing something with a load-bearing beam in it. I want you to try to get to something a little bit more specific than that, and that is the challenge. Okay, including a diagram or a picture or a photograph is really helpful. All right, so how do we do that? Okay, so let's put me to the test. Picking one of these things by random. If I went to like a random number generator, I could generate one of these. I did, just to practice for this video, I did about 5 of these topics, and I would say each one took me a good half an hour to really drill down into. It is not just a simple Google search type of thing, because you're really trying to find a specific fact where you are going to use a derivative or a rate of change. Okay, so trying to pick one of these new ones here. If I did medical, for instance, okay, and then I go to, whoops, you can't quite see it. Let's see if I can drag it over here. If I get to a new tab, okay, and I'm going to do some rates of change calculus connection with something in the medical field, I would, in your Google search, I would say something like application of calculus to medicine. You could try that, or specific and just see what shows up. And then when you get your possibilities, sometimes it's just looking through these. So here, applications of calculus in medicine. So here's an article that seems, it's a presentation, so maybe that's a good thing. Applications of calculus to dentistry, that would be totally fine. What is the point of calculus? So here they're going, so this looks like a pretty good start. Rates of change, so this is some kind of a presentation. If you can find a specific example, interesting. So this was someone's presentation about application of calculus in dentistry. All right. So it is okay to completely, take advantage of somebody else's research as long as you understand it and present it. Don't just photocopy it and paste it into your Padlet, right? Really be able to explain what is going on here. And so I would read through this and see if this gives you a good explanation as to what they're doing here. You don't have to have numbers, you don't have to have an equation, you don't have to actually take a derivative, but you need to be able to point to some specific example where an understanding of a rate of change is used. All right, let me go back and just see if there's something else I can find. Examples of calculus use in medicine. Homeschool Math Blogspot. I think that doesn't sound bad. Okay, so this is about metabolizing drug amounts in the bloodstream or something like that. Yeah, that looks pretty promising. Um, I think as I've looked, I've also found it useful. Let me just see what this is. Oh, so I would stay away from things that are not fully secure. So I'm going to back away from that slowly. Unlikely that there's a problem if you're dealing with, um, you know, medical field and things like that. But you never know. Just got to be careful. Okay, so that might be also, anytime you're talking with half-life, that's an exponential decay. Calculus can help with that, and also with exponential growth, and particularly in logistic curves, they're called, because that's something that calculus can be very useful in dealing with. Differential equations are the source of a logistic curve. So here's again, it's just a matter of trying to hunt these down. But one of the things I found when doing a search is if you look for like textbook or PDF of textbook, PDF of, whoops, can't type, of exercise with application of calculus to medicine. The web is a big place, and there are many professors out there teaching courses similar to this in college that are trying to find real connections to real fields, and they might have an exercise and it'll be a PDF. So you would be surprised. Calculus, application and theory. Okay. Applications. Okay, integration. Stay away from integration. That's an advanced calculus technique, but here's going to be a PDF of probably a textbook, and if you can find an exercise or a section in the book that deals with this, it might be a really good source. So there we go. Calculus, applications and theory. This looks like it's either a paper or a college textbook, and you can look through the contents. Functions, derivatives, here we go. So exercises, and this is probably going to have a chapter on applications. Here we go. Properties and applications of derivatives, page 149. Okay, and then there might be exercises in there that have those, and you might find one that is on medicine. Our textbook, the other calculus class we teach at Pingree, has some examples in the textbook. So I would say that's, try to make it as concrete as possible, and that is at least a start, I hope. Then the second part of this is where you're doing something theoretical, okay? And this is also easily done, I think, through Wikipedia, through any one of hundreds of sites where you can say, I'd like to look at the proof that the derivative of the cosine is what it is, okay? And I don't even want to give that away because that should be in your helpful 3x5 card. And then type in limits approach, and you will hopefully find that, again, in a textbook. In our own calculus textbook, you'll find examples of these, and then see if you can set up, based on the limit definition, the derivative of this, and then apply your math skills to get it set up. And then reach out to me when you've got it set up, and I can help you figure out how to complete it. I don't want to set it up for you, but I can certainly help point you in the direction of the limit definition of the derivative as it applies to your topic. That should really only take about half an hour, 45 minutes, an hour if you get stuck and you need to get a little help from me. I would say divide and conquer between your group. Maybe one person could begin with one part, another person could begin with the other part, and then teach each other and help each other and explain to each other what's going on. Divide and conquer. Okay, good luck, everybody.